Hello and welcome to another video with it's Dr. Dan, and here what we're going to be doing is introducing Lewis structures. So for Lewis structures, it comes down to just a set of simple steps in order to be able to draw how different elements are covalently bonding together. So we're going to be focused on covalent molecules, meaning that we're going to be looking at the sharing of electrons. So how do we go about doing that? So the first thing that we're going to really be trying to look at here is we're going to be trying to count the total number of valence electrons. So it's really helpful if you're using a periodic table to be able to go through that and know your different trends for counting valence electrons. The next thing we're going to be doing is choosing the center of attention. So, which atom out of all of them can bond to the most things? So, for example, carbon has 4 valence electrons, meaning that if it wants to fulfill the octet rule, so to have a total of 8 electrons, it needs to bond to 4 things. So that's 4 bonds. It's usually the center of attention for most structures. Other things that are going to do is then place all the elements around your central atom, draw the skeletal structure of it. So using single bonds to show that. So we'll go through that. Next, we'll assign all the remaining electrons to make sure everything is happy and has satisfied octets. And we'll go through a couple of different steps showing that. So, all right, let's get started. How do we go through trying to do this? So I have a periodic table here ready to go, just like I was recommending. We'll zoom in and out of that just so we can kind of show how do we pick the different structures. So let's do something that's normal to all of us, something that we probably drink every single day. So why don't we start with water? What is the valence or the Lewis structure for water? So the first thing is we have to count our valence electrons. So if you remember going back to our periodic table, really that comes down to a very simple trend for how to count valence electrons. So if we look at our main group elements, so that means the 2 side columns, so the 2 on the left here and then the 6 on the right, these are our main groups. The numbering is as simple as looking at the Roman numerals on top. So we have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons for all these different species. So if we have hydrogen is right over here. So that's on column number 1. So that's going to be 1 valence electron. Oxygen is over here on 6. So that's going to have 6 valence electrons. So when we are writing that down and drawing that structure out, we're going to show that our hydrogen has 1 valence electron. And there are 2 of them, so make sure we keep that in mind. And then we also have our oxygen, which has 6 valence electrons, and there are 1 of them. So when we do that little simple math for ourselves, it'll be 6 plus 2. So this tells you that, okay, well, we have 8 valence electrons in total. So why is that important to count them every time? Well, when you're going through the process of drawing these structures, you want to make sure you have the same number of valence electrons that you start with and that you end with. You don't want to make some crazy structure. So let's write that down for ourselves. Same valence electrons. So remember that for later for yourself is have that number. So out of these, which one can make more bonds? So remember, we want to satisfy the octet rule, which means that we want to have a total of 8 electrons. So if we have that total of 8 electrons in this particular structure, let me move that over because I realize that's getting cut off, is how are we going to be showing those 8 electrons? Well, oxygen can make 2 bonds to fulfill 8, so that's 2 bonds. Hydrogen can make 1 bond. So what that means is that, all right, oxygen can make more. So that's going to be our center atom. So when we are doing that, we are going to take that center atom, we're going to write its 6 valence electrons around it. So we have 1, 2, 3, 4, 5, 6. Now we are going to put the hydrogens around it. So we have our hydrogens like so. Each one has 1 valence electron. and we are going to connect them with a single bond. Now, we want to check, does everything have a happy octet? So with oxygen, one thing, how can we count them? So if we kind of zoom in here for ourselves, we can see that it has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons that are being shared with oxygen. So it's happy. Now, what about hydrogen? Hydrogen's a little strange. If we kind of look at a hydrogen, we only see that there's 1, 2. Is that happy? Well, the answer is yes, it is. So if you remember looking at our periodic table, and you go back to valence electron or electron configuration from probably a long time ago when you first covered electrons in your chemistry class, hydrogen is 1s1 for its electron configuration. And when it's on that second row, it can only go up to 1s2, meaning that hydrogen only needs 2 electrons. So hydrogen follows a Duet rule, meaning it only needs 2. It only takes 2 to dance. Oxygen is going to be the octet rule. They are both happy in this case, so we can give them little check marks. We have our Lewis structure. So if we want to clean that up for ourselves, we can. We can write hydrogen, write the little lone pairs for that, and draw another hydrogen. So whenever we have little dots like this, these are referred to as lone pair electrons. And you can see that we have 2 sets of them. We also have our single bonds. So that's 2 electrons. And the single bond represents 2 electrons being shared. Okay, so those are being shared between those 2 elements. Okay, so let's try a different one. What if I ask you to, what if we do another common element? What if we do something that we breathe in? So oxygen. So if we breathe in oxygen, how would we show that Lewis dot structure? Well, same idea, right? We count the number of valence electrons. So if you remember from last time, oxygen had 6 valence electrons. So there are 2 of them. So that means this whole entire species is going to have 12 electrons. So being there's only 2 of them, we're not going to have a central atom because they're both just bonding to 2. In order for something to be central, it has to be bonding to 2 or more. So why don't we write that down? Central atoms, and you can have more than one, have to be bound to 2 or more species. And when I say species, I mean atoms. Okay. All right. So if we have oxygen, we will write that we have an oxygen that has 6 valence electrons around it, just like so. We will draw another oxygen. We will write its 6 valence electrons around it. We will connect them with a single bond, right? So we'll start off there. Now, are they happy? Looking at them, do you count 8 valence electrons around each oxygen? So if we kind of like zoom in on this, well, we can try counting them. So if I do, let's count the ones for the oxygen with the purple electrons. So when we do that side, we see we have 1, 2, 3, 4, 5, 6, 7. So it's not happy. Well, if you remember from before, I had one step for how to fulfill these. So once you assign all of your valence electrons, you're going to use double and triple bonds to fulfill everything until it's all happy. So we're going to be doing a double bond in this case. So when we have a double bond, as you can see, both sides have this extra electron. They're both going to move and interact with the bonds. So we're going to move both of those to the middle here. We're going to erase them. So we still have them on this side, but instead now what we're going to be doing is making an additional bond between the 2 atoms. So when that happens, we now have a double bond. So that allows us to have our 8th electron now being shared. So we now have a happy octet for each species. So oxygen is going to have a double bond. Now, what other species can we do? What else do you breathe in? What else is part of air? Well, okay, you have oxygen, nitrogen. So why don't we try nitrogen? How would you go about doing that one? Well, how many valence electrons does nitrogen have? Let's go to our periodic table. And we can see that, all right, nitrogen's on column 5 here. So what that's going to tell you is that, all right, it has 5 valence electrons. So when we do that, we will write our nitrogen, draw its 5 valence electrons. So you can see how many bonds can nitrogen make. You can see that it wants to make 3 bonds because it has 3 electrons that are by themselves. They want to make a friend. So if we're doing N2, this might give you a hint of what the structure is going to be if it wants to make 3 bonds. Well, the first thing we're going to do is we're going to bind 2 of them. Is it happy? Well, right now each one only has 6 electrons, so definitely not. So what we can then do is redraw some of these and move them. So if I move 2 of them here and here, I can connect them. Oh, I'm using a different color. We can reconnect them. So now we have 2. Now notice if I kind of count these, right, we have 1, 2, 3, 4, 5, 6, 7. Still not happy. So we can add another one and make a triple bond. So when we do a triple bond, that's going to move another electron over to the middle and connect them as well. So when we do that, now we have how many electrons being shared? There are 6. Oops, that's a little too big. We have 6 electrons now being shared. 6 shared electrons. When we did a double bond earlier with oxygen, we had a total of 4 shared electrons. So with every bond or every line you're drawing, you're adding more electrons that are being shared. So with that, there's a small little tip here that you can try to remember for how to quickly draw these. So one thing you might have noticed is that depending on the number of valence electrons, there are bond trends that we can see here as well. So if you remember, oxygen had 6 valence electrons. So how many bonds did it make? It made a total of 2 bonds. Well, nitrogen, it had 5 valence electrons, so it can make 3 bonds. We didn't draw a carbon, but carbon, like we said before, had 4 valence electrons, so that can make 4 bonds. So if you kind of look at this trend that's going, if you go to the right, it goes 4, 3, 2. Well, you can probably take a guess that it's 4, 3, 2, 1. So there's a trend here for yourself for remembering the different bond trends. So if you kind of write these down for yourself, it makes Lewis structures really quick to do. So let's just do a couple more examples with each other just before we kind of sign off and see how we do. So what if I do what we breathe out? What if I do CO2? How would we draw that out? So the first thing we gotta do is figure out how many valence electrons can they make. So if you remember, carbon is on that 4th column. So what that means is it has 4 valence electrons, nitrogen 5, oxygen 6, 1. So that means that carbon is going to be making 4 bonds and has 4 valence electrons. So let's draw that first. So we have carbon, we have our 4 dots, we have our oxygen, which had a total of 6 dots. And one little tip, as you can see, I'm always lining up the single electrons with each other because you want to connect them all with single bonds first. It makes it a little bit easier on yourself and a lot less erasing when you are doing these different bonds. So we fill in our 6 valence electrons on each of these. We'll connect them all with a single bond. Now, going back to our trends, how do you know the structure? Well, carbon wants to make 4 bonds. Each oxygen wants to make 2. So you can maybe take a guess if each oxygen wanted to make 2 bonds, carbon wants to make 4 and 2. Well, what can satisfy that is your double and triple bonds. So if I move one of these to here in the middle, notice how on the left side now, oxygen is now making 2 bonds. It's happy. And in the process, we get rid of one of those lone electrons. We'll do the same thing here on the other one. And we will make the different bonds. So notice how we have 4 bonds, 2 bonds, 2 bonds. It makes a perfect structure for CO2. All the electrons are accounted for. We could count them all. We could see they're all here when you're going through that process. So let's do another. What if we do NH3? What is going to be your central atom? Well, what can make the most bonds? Well, if we look at our little list, nitrogen can make 3. Hydrogen, which is hidden over here, can only make 1. So nitrogen is going to be your central atom. So if we do nitrogen, we know from before it has 5 valence electrons. So we have 1, 2, 3, 4, 5. Then we'll fill it in with all the hydrogens all around it. So we'll put hydrogens on all sides. Where the single dots are, we'll put dots here, here, and here. And now we will connect them all with a single bond. And now you can see we can count and double check for ourselves. Do we have the right number of electrons? Well, if I take a look at that, we have for nitrogen, we have 1, 2, and those are the 2 for hydrogen as well. 3, 4, 5, 6, 7, 8. So everything is accounted for in our structure. We have all of our electrons and we're making them all. Let's try something a little bit harder in terms of trying to figure out structures. So what if I give you CHOCl as a structure and you're like, what the heck is that? How do we figure out what the structure is? Well, it's simple. We can try to just figure out what the number of total bonds for each species. So if we go up to have our chart up here, well, we can label everything for how many bonds it can make. You know that carbon can make 4, hydrogen's 1, oxygen's 2, chlorine is also 1. So what's going to be your central atom? It's going to be carbon. It can make the most bonds. So that's going to be the center of attention. So if that's the case, well, all right, that's our bond, so I'll write that down. Carbon is going to be in the middle with its 4 valence electrons. And now what we're going to do is we're going to space out the other species on all sides. So let's start with hydrogen. So hydrogen has 1 valence electron. We'll connect that to carbon. Okay, so hydrogen's happy. We don't have to worry about that. Now let's put chlorine in. Chlorine, why am I skipping oxygen? Chlorine only can bond to one thing as well. It has 7 valence electrons, and we can double check the periodic table so we can see chlorine is right here. It's on column 7, so it needs 1 bond. So if that's the case, why don't we do that one real quick? So we'll have chlorine down here. We'll have 1, 2, 3, 4, 5, 6, 7. We'll connect that. Now, how many bonds can oxygen make? Well, if you remember, it can make 2, and there's still 2 single electrons that are available over here. So being that those are still there, it's going to be making a double bond, and you can see that here in a second. So if I put oxygen in, and I put its lone electrons at 1, 2, 3, 4, 5, 6, we will connect those. Notice how oxygen still has a single electron that's by itself. It does not want a single electron. They want to all be paired. So we're going to move that and make a double bond. Okay, and now we have our happy structure, just like that. Now, let's do one last one. Why don't we do something with a charge on it? So, a charge. So, if I give you Cn minus, okay, so what does that tell us? So, if you remember from before, if I have a negative charge, what this tells you is that on this molecule, there's a negative charge located somewhere on it. It doesn't have to be on the nitrogen, it could be on the carbon, it's on one of these species. A negative tells you have 1 extra electron. A positive tells you have 1 less electron. Okay, so that means that when we do this, we're going to have one more electron. So if carbon has 4 valence electrons, nitrogen has 5 valence electrons. We're going to be getting one extra from the negative charge. So we're going to have a total of 10 valence electrons. So let's try and draw it. So let's write out our species. So if I start with carbon, carbon we know has 4. Nitrogen has 5. So we'll start by connecting them first with just a single bond. Notice how neither are very happy. So one thing what we'll do is we'll maximize the number of bonds, which is 3, right? 3 is the ultimate. Also, nitrogen can make up to 3 bonds as well. So, and carbon can do up to 4. So why don't we do that? We're going to rearrange all these so that way we can start with a triple bond. And we can see that, all right, well, nitrogen's happy. Nitrogen has 6 electrons being shared. And then the 2 up here. Now, how can carbon be happy? It has a lone electron all by itself. What can it exactly do in that case? Well, don't forget that we have that one extra one, so we can put that in the spot where it is most needed. So in that case, we now have a happy structure, and the only thing that's left to do is, being that there's a charge, we're going to put brackets around it with a negative charge, just like so. Okay, so that is how you can go through and do Lewis structures. If you need any future help, please don't hesitate to reach out, and I will be making more videos to come. All right, this is how you can make Lewis structures, and this has been Dr. Dan. Please consider hitting that sub and like button, and I hope to see you in the future. Bye now.